Hi, my name is Rihanna Kenzie, and a topic I find fascinating in science is the concept of entropy. The Merriam-Webster Dictionary defines entropy as the degradation of matter and energy in the universe to an ultimate state of inert uniformity. More simply, entropy is the tendency of the universe to move towards disorder. Think of the universe moving towards a uniform soup of molecules. Now, I know this seems extremely macabre on the surface, but the deeper you go into the topic, the more fascinating it becomes. Think of a simple molecule with maybe 5 bonds. Now, the energy in the bonds of the molecule is constantly moving around to different microstate configurations. Entropy is the direct measurement of the likelihood of a certain microstate of energy in the substance. Now, I'm not going to explain the statistics behind it, but the microstates in which the energy is more spread out are more probable than those where the energy is all smushed together in one spot. Although it would seem to an untrained mind that all cases would be equally likely, it's way more probable that the energy will keep spreading out for eternity. This is the second law of thermodynamics. The universe is actively spreading out and increasing in entropy. The more things spread out and separate, the less ordered they are and the higher entropy they have. Since natural processes have a high likelihood of increasing the universe's entropy, an entropy increase is considered an irreversible process. Even really simple processes where you would assume that you could reverse them, they always have dissipated energy, which increases the entropy. Processes like this that occur without prompting or added energy to move the process along are called spontaneous reactions, and those increase entropy. Up until the discoveries of Josiah Willard Gibbs, to determine spontaneity, you had to measure the entropy of the environment and the system, which, depending on who you talk to, is either extremely difficult or impossible to do. Gibbs described the process of free energy, which is a measure of the amount of usable energy in a system and captures the effect of a reaction on the entropy of the universe. The equation Gibbs created is the change in free energy is equal to the change in enthalpy minus the product of temperature and change in entropy. When the change in free energy is negative, the process is exergonic and proceeds spontaneously. When the change in free energy is positive, the process is endergonic and would need a little prompting to occur in nature. But it's possible that the endergonic process might occur backwards spontaneously. Because of the second law of thermodynamics, all systems tend toward the lowest energy state, so changes in Gibbs' free energy are generally negative and further increasing the entropy of the universe. I find the concept of entropy fascinating because of how it fits like a puzzle piece into everything the scientific world knows about the universe. For example, the expansion of the universe. Entropy has a role in that because the constant acceleration of everything in the universe away from everything else infinitely increases the entropy of the universe. My only question is what happens if the universe stops expanding?